Hello there. In this lecture, we are going to talk about the server-side attacks and server-side injection mitigations. When you're accepting data from the user, you have to be aware that the user might be malicious. So first and foremost, you have to know your inputs. You have to know exactly at what input field, what kind of data you're expecting. And make sure that you don't accept anything else, just what you wanted. So if it's an input field for a name, then just accept names. If it's an input field for full email addresses, then make sure that it's just an email address and nothing else. When you're using data in the application, you have to always think about where this data comes from. Because sometimes you just load the data from a database, and for you, it's just some random data of the application, but maybe at some point it was created by a user, so it can be still potentially malicious. For instance, I've seen once a cross-site scripting attack where the web application was just showing the system logs on the website, but you could make a cross-site scripting by loading a URL with a malicious string in it. And even if this URL didn't exist, it was logged by Apache in the system log. And when this log file was loaded in the application, then the cross-site scripting was triggered. So the programmer thought that the log files are secure because they are just files on the server, and didn't think about that the data inside the log files can still come from the users, even from malicious users. So think about where the data comes from, and if you think that it can be malicious, then do the appropriate checks. Actually, it's even better if you always do checks without thinking about whether it can be malicious or not. Most of the programming languages and frameworks offer some kind of features or functions to escape strings before using them, for instance, in SQL queries. Also, regarding to SQL injections, you can create prepared statements, which means that instead of concatenating the query together, the parts of the static parts of the query with the user input, you can create a query object and then fill out the blank spots by adding values to the query object. In this case, the original query string and the inserted values are kind of kept separate, which usually stops SQL injections, although there are always some kind of bypass attacks, but the risk is much lower. You can also use various frameworks which wrap the whole SQL communications. So for instance, what we've seen in Django, that's something like that. Because in Django, you're not dealing with the SQL server directly. So you're not writing SQL statements, you're creating a Django model, and you do all the communication with the database through this Django model. So basically Django takes over the database management for you. And in this way, Django itself can implement security mechanisms against SQL injection and various attacks. So using such a framework can decrease the risk of a single programming failure, and you also enjoy the constant support of the community. With this, you are finished with the server-side attacks section. As always, I recommend you to stop a little bit, recap what we've done together, and as always, experiment a bit more. But otherwise, congrats for finishing this section, and you're almost at the end of this course. So I will see you in the next section. Bye.